We have already learned that when simplifying rational expressions, the key words are factor and cancel. That will be true for multiplication and division also. Basically, we want to factor each corner of this problem, so to speak. In the top left, factor out a 2 in order to have p minus 2. I'm just going to bring the 4p squared back up again, and down below, no change in the bottom left corner, but on the bottom right we can factor out an 8 and have p minus 2. So we want to factor each of these four corners before we then cancel, because we're only allowed to cancel factors. The first thing I'm going to cancel are the p minus 2's. They're gone, and I'll replace them with 1's. I can cancel a p with a p squared, just leaving a p up in the numerator. And I notice also that 4 times 2 is 8, and so I can cancel all those at once. Now what is left in the numerator is just p, and all that's left in the denominator is the 6 at the far left. If you are the type of person who likes to do a bunch of scribbling as you cancel, I normally don't suggest that because you can't rework your problem, but if you're the type who misses and can't find your p or leaves things out of your solutions, perhaps scribbling out is the best way to go so you can physically see what is left for your solution. This next problem is written in a different form, but it really is the same type of problem as we had just a moment ago. We have a fraction divided by a fraction. So I'm going to rewrite this as p squared minus 6p plus 8 over the 24, and instead of dividing by this other fraction, I'm going to multiply by the reciprocal of the other fraction, 6 times, well, I'm factoring it now, 6 times p plus 1 over this 16 minus p squared. I think that was just an automatic response on my part. Now I have four corners that I want to factor, and in this top left corner I want to factor it a p at the beginning of each parentheses, and in order to multiply to this positive 8 and add to this negative 6, we're going to have a minus 2 and a minus 4 within the parentheses. The top right is already factored, and the bottom right we're going to factor into 4 plus p and 4 minus p. Now that each corner is factored, we can start our cancellation process. And I notice that we have a p minus 4 and a 4 minus p. Using the -1 technique, we can cancel them so that one of them is a -1 and the other is a +1. And we can also cancel the 24 with the 6 on that diagonal, giving us 1/4. Now we need to put together what we have here, and I'm going to have a -1 times this p minus 2 times p plus 1 over 4 times 4 plus p. And if I want to rearrange that and write that as p plus 4, that's perfectly fine. It's the commutative property of addition that says I can do so. For number 3, we're going to begin by factoring the top left corner. We can take a 6 out and have a minus 1 left over. In the top right, I can factor an a out and have a plus 5 left over. In the bottom left, I have a plus 1 times a plus 5, and I'm just going to leave the 12a in the bottom right corner. Now we begin our cancellation, and I see that the a plus 5's will cancel directly. I see that I can cancel an a in the second fraction, and that is all that I see that can be canceled. Oh, sorry, I have a 6 and a 12, which reduces to 1/2. Now that's all I can cancel. This leaves a minus 1 in the numerator and 2 times a plus 1 in the denominator. And again, if you wish to distribute the denominator, you're welcome to do so. Number 4 is a division problem, and rather than rewrite the whole problem over again, what I like to do is, when I factor, switch places with the numerator into the denominator and switch this to a big multiplication sign. Now I can factor the top left into x minus 2y times x plus y. There will be no change in the bottom left corner. Keep that, x plus 2y. In the top right corner, when I factor it, I'm going to bring that factorization down below. That will become x minus 2y times x minus 2y again. And when I factor the difference of two squares in the bottom right, I will put the factorization up in the numerator, leaving x plus 2y times x minus 2y. Now I can start to cancel, and I see that x minus 2y's are directly above and below each other. No problem canceling there. I have another pair of x minus 2y's that will cancel on that diagonal. X plus 2y will cancel on the diagonal, and all we have left over is x plus y up there in the numerator, and so that is the final answer. Now, had everything canceled out, our solution would not have been 0, the solution would have been 1. When we are looking at rational functions, it's okay if the numerator is equal to 0, it's the denominator we have to be careful of. Now, if I rewrite this function as h of x is equal to x minus 9 times x plus 3 over x plus 9 times x minus 9, we do see that the x minus 9's will cancel each other out. However, when we're finding the domain of this rational function, we only look at the original function, not the factored and reduced form over here, x plus 3 over x plus 9. The domain will need to exclude both plus and minus 9, and therefore the domain will be negative infinity up to negative 9, united with the numbers between these two values, then united with the numbers to the right of positive 9. Let's look at the domain of these final problems. In this next one, f of x is not allowed to equal negative 8. So the domain will be negative infinity up to negative 8, excluding that number, skipping over it, and then from negative 8 on up to positive infinity. For the next problem, we will have to exclude both 0 and 4. X cannot equal either of those values. So the domain will be from negative infinity up to 0, united with the values between 0 and 4, united with the values to the right of 4. Finally, for h of x, we note that the denominator factors into x plus 4 times x minus 4. We don't worry that the fact that the x plus 4 will cancel with the numerator. We only look at the original problem, and we see that x cannot equal plus or minus 4. So the domain will be very similar to what we had up above, from negative infinity on up to negative 4, united with negative 4 to positive 4 between those two values, united again with the interval off to the right.